Good morning, everyone. I'm Neha, Ambassador of Change for GETI, that is Global Education and Training Institute, founded and conceptualized by Dr. Sunita Gandhi, with the vision of disrupting education, the education movement as we know it. We also organize various pre service and in service trainings for teachers so that they can help us spearhead this disruptive education movement. Alongside, we also organize tea talks where we invite policymakers, researchers, educators, and various principals from around the world to discuss these best practices with us. And today, I am very honored and thrilled to have with us Ms. Divyanshi Malhotra, who is the mentor at Unmath School Private Limited, and she's based in Sitapur, but she is operating around the world from Lucknow. A very warm welcome to you, Divyanshi. Thank you so much for joining us this morning. So sorry.
Thank you so much. Thank you so much, Neha, for that wonderful introduction. And I would like to thank Getty for this wonderful opportunity, along with my own edtech company, Unmath School, where I am working as a content curator and a math mentor, as you just mentioned. And yes, I can proudly say that sitting at home, I have been operating like teachers as well as students from various countries. As you all know that Unmath School is in 6 countries. We are catering the students and the teachers from Asia, Middle East and USA. So thank you so much once again, Getty and Unmath School Private Limited, for trusting in me, believing in me, and training me so that I am just going to share my experiences with a topic, creating math based experiences to the educators and my lovely audience from all over the world. Thank you so much. So, should we get
Ab-
started?
Absolutely. We can get started. Can you add your presentation to the screen, Divyanshi?
Sure.
Okay.
I hope the screen is clearly visible.
It's absolutely visible. Divyanshi, you can now take the stage.
Perfect. Thank you so much. Thank you so much, Neha. Once again, thank you, Getty. Thank you, Unmath School. I'm just about to begin. So, as you can see, that my topic is creating math-based experiences. Now, obviously, since I am a math geek, you can say, or maybe my forte is math, but it's not just about creating math based experiences, it's all about creating experiences in your classroom. I would just like to start with a very famous saying that experience is the best teacher. We all know it, it has been saying to us again and again that if you have failed in something, just try it out once again, because if you're failing in something, you are just a step closer to the success. That's absolutely right. These saying are not just that they are saying, but yes, they actually mean something. And if I say that creating math based experience, I'm going to talk about this topic, I will be extensively talking about experiences and not rather math based experiences. So you must have heard, like, when a child starts walking, what happens is they never walk or they never talk by just looking at someone. When they actually start walking, then they learn how to walk. Many the times they fall, they get up, they start walking again. And as a parent, as a mentor, we always ask our child to just get up and walk once again. If we are not able to pronounce, let's say, any word, we again and again try to inculcate in ourselves that how we are going to, like, pronounce that word. So it's all about experiences, how you are experiencing that particular thing. And at Unmath, we are just trying to experience this particular habit in studies as well. We are trying to make our learners, make our teachers experience mathematics. But again, as I said, it's not always that we are talking about mathematics. I am talking about mathematics, but my audience can just take it as a general experience, how they can create experience in their subject as well, whether it is science, whether it is English, whether it is any other subject that you are specialized in. So with that note, I'll just try to I'll just move forward with my presentation, and I'll just like to throw a light upon the presentation in various modules. So I'll be just starting with the first module of my presentation, which is the ideology of unmatched school. The ideology that we have been following extensively in unmatched school is number literacy and number interpretation. When I say number literacy, we all know that a child knows what 2 looks like, what 4 looks like. But if I just ask a child, you have to make 6 out of 2 and 4, he will just tell me 2 plus 4 is 6. Now, if I ask, okay, you have to just tell me one thing other which is adding up to 6 again, they will said maybe 1 plus 5. So number literacy is where a child is just understanding the subject, they are performing the calculations. That is number literacy, which has been forte of all the teachers, many teachers, students, and everyone. Number literacy. But if I talk about number interpretation, we strongly feel that number interpretation is something that needs to be worked upon extensively. Because when I talk about number interpretation, you must have heard many of the students saying where we are going to use it, why we are learning this. Let's say if I'm talking about any topic, let's say algebra, or maybe let's say data handling, it can be anything. The students have a very common habit of asking where we are going to use this, why we are studying these baffling topics. There comes the role of number interpretation. When you say number interpretation at Unmath, we mean it in two sets. First is subconscious learning approach, and second is acceptance rejection model. You must have seen in the books there are like questions like 70 watermelons, 80 oranges. Are they even making sense to the child? Like they cannot even imagine of 70 watermelons and 80 oranges getting sold, because obviously they are not relevant. So what is happening over here is, when I say number interpretation, I talk about two topics mainly. First is subconscious learning approach, wherein we are asking a child that this is the skill set that you are covering, but subconsciously you are learning something or the other. You have to explore, you have to investigate on yourself what is your subconscious learning approach. Because when a child is performing addition, they are not just performing addition, they are performing many other things as well. If I just talk in general sense, if a child starts walking, they are not just looking at a path and then walking. The child can look here, the child can look there, and then also he can walk. Obviously, I understand that the child needs to focus when he is walking. But at the initial stage, the parents are asking them to focus. But once the child has a habit of walking, they are not even bothered about it. They are just walking. We are just focusing on the same lines, that number interpretation. When I talk about subconscious learning approach, it's very important to understand that when a child is learning something, they should experience it. They should not mug it up, but they should experience it. Because as I always say, I have a habit of saying this, that if a child is able to visualize it, they are never going to forget it. Because if we are walking, we have learned how to walk, we have learned how to talk, we are never going to forget it. Obviously, we know we have practiced it later, but first we have experienced it. That is something subconscious learning approach. Second is AR model. This model is acceptance and rejection model. When I say I bought 70 oranges, can I can my mind accept it literally? Because are 70 oranges or 80 watermelon or anything like this is making even sense to me or not? It's not, obviously. So the child has, or the mentor or the learner, the trainer has full right to accept or reject that model that has been presented to him by his mentor. Because if they feel that this is not making sense to them, obviously the mentor is going to ask them why it's not making sense to you, what is your perspective, because every child is unique, every mentor is unique. So when I'm doing either teachers training or if I am doing individual mentoring wherein I am training a child, it's always that I can ask them, okay, can you please explain me your perspective, what is your perspective to this, why you are not accepting it, why you are rejecting that model. So this should be like, a child should have a hold wherein they can accept any model or they can reject any model. This is the basic ideology of unmatched school that we follow when we are creating happy classroom, when we are creating experiences, not only math based experiences, but yes, general experiences as well. Moving forward, this was the ideology. Second is, if I just ask about what is experiential learning, I don't think so that creating math based experiences or experiential learning is anything different. As I always say, experiential learning is learning by doing. If a child is performing an activity, they are never going to forget it. As a child, when we are taught the basic addition, fingers comes into consideration. If I am asking my child, you have to add 4 plus 2, I'll show 4 fingers to him, I'll show 2 fingers to him, and then I'll ask him total fingers. 6 fingers are there, he will quickly give me the answer because he can see the visual representation, he knows what 4 looks like, what 2 looks like, and then they are adding it, and then they are telling me the answer, okay, 6 is the answer. What happens slowly and gradually is, in the lower grades like kindergarten or maybe grade 1, grade 2 till grade 3, I would say parent as well as mentors are very much interested into experiential learning, because they think that hands on learning, hands on activities can be done very easily and the child can also understand the concept. But slowly and gradually, after grade 3 or grade 4, what happens is they are just into books. They are not beyond textbook at all. When they need to be beyond the textbook, they are not beyond the textbook, but they are just into the textbook. And what happens is, since they are into the textbook, they stop exploring things, they stop investigating things. And what happens is, they are just busy solving the questions, they are just busy mugging up the formula. I completely understand. Might be a possibility, whosoever is listening to me, might be a possibility they think that this is not practically possible in few of the classes or maybe few of the skill sets. But trust me, it's practically possible. I have been doing it till grade 12. I have been taking the students till grade year 12 and I have been experiencing this. I completely understand that if I am taking functions, obviously I cannot teach them functions without making them plot a graph. But when they are plotting a graph, there are many things that you can make them explore. You can give them the real life applications. That is also learning by doing. Instead of just opening any book, it can be any book of maybe CBSE board, ICSE board, IB board, it can be any other book. You have just opened it, you have started solving the questions. No, that is just number literacy. But the need of the hour, the need of digital India is number interpretation and not number literacy. Because gone are the days when you are just like getting through any job or anything, any college, any scholarship, wherein you are just like a human calculator and you are just getting it through by your number literacy. You have to interpret the situation as well, which is very important in the scenario like today. And since as COVID had settled in, it has taught us many things sitting at home, how we can collaborate, how we can reach out to wider audience, how we can give our time to not only a group of people, rather global. So this is I would like to say experiential learning is, which is learning by doing or maybe hands on learning. So trust me on that part. If it is grade 1, grade 2, grade 3, if slowly and gradually you will start curating your lesson plans in a manner, in an order wherein you are able to connect your child with the real life scenario of it. Let's say I'm taking a very simple example of money or maybe currency denominations. I'm teaching my child currency denomination. Now, if I will give him a dummy currency, it will become a lot more easier for him to understand, okay, I have dummy currency or maybe original currency in my hand. Now I need to curate, let's say I have to give 25 bucks to the shopkeeper. So he has multiple options to create those 25 bucks from the denominations that you have given him. And that is what experiential learning is. This is how the child can visualize what 25 looks like. 20 plus 5, can he can give it to the shopkeeper. He can also give 18 plus 7 to the shopkeeper. And even if he has not having those kind of denominations, even he can give 30 rupees and take 5 rupees in like back. So this is experiential learning all about. And if we'll just start learning in that manner, it will become a lot more easier for the teachers as well as for the learners to understand the concept, how they are learning. Moving forward, after experiential learning is making math meaningful and engaging. This is seriously the need of the hour, wherein we need to keep our books aside, whatever grade it is. I'll say that again and again, because it's the biggest myth that you cannot use experiential learning from grade 8th or grade 9th onwards. It's nothing like that. I completely agree. Few other topics wherein you have to do hardcore learning. But again, if the child has understood the essence, how they are going to learn, how math is making meaningful to them, or any subject is making meaningful to them, it will become a lot more easier for them to understand. With that note, or with that ideology, I would like to present Cray model in front of you, to all of you. And the audience who is viewing this, I would request if you can implement this Cray model in your daily lesson planning, in your classrooms, anywhere. It will become a lot more easier for you. Cray model is creativity, relevance, exploration, and investigation. Now, when I say creativity, obviously it's completely out of the box. It can be anything that you are curating as a child or as a teacher. It can be anything. It's just that you have to think out of the box. Like, let's say I want to teach subtraction. Might be a possibility I'll take subtraction using Jenga blocks. Might be a possibility I have to take shapes. I will be using Play Doh and toothpicks to teach my child shapes, because again, as I said, if I will make a model wherein the child is also doing a hands-on activity and making a 3D model of a cube, of a pyramid, they are never going to forget it, how many sides are there, how many vertices are there, how many faces are there. And it will become a lot more easier and interesting and engaging for them as well, to explore how they are going to make it meaningful. That's the first thing, creativity. Second is relevance. Now, relevance is, again, as I said, the students have a habit of asking questions where we are going to use it. Now, it's very important to make them understand why and what. Why you are using it, what will happen if you will not use it. So, that is something, the relevance of that particular topic, the relevance of your creativity. It can be anything, the relevance can be of anything. Third is exploration. When I say exploration, I am particularly talking about math. But again, when I say exploration, it can be anything. I understand, like as a child, I remember I used to sit in basling sun, and I used to just make mitti ke bartan. So like, once I'm back from school, I cannot forget those days wherein I just had my lunch, I had everything, and as a child I'm just sitting in the basling hot sun and making those mitti ke bartan. But it has something that has given me an essence to explore. I can explore that, okay, if I am molding it like this, it's going to take a shape of a, let's say, fry pan. If I'm molding it in some other way, it's going to take a shape of a glass. It can be anything. So the exploration for a child is literally very important. If they are asking questions, let them ask. Might be a possibility their question is not correct. but we all are here to correct them. But if a child is not asking the question, that is the problem. If they are not asking the right question, that's not the problem at all. We are here to help them out, we are here to correct them. But the major point is that they should ask the question. We should inherit this particular thing right from the starting, that they should explore the thing, they should not hesitate in exploring the thing. That is exploration. And when I say investigation, the young scientists, the scientists in India are not formed in a day. They have to investigate, then only they are coming to a conclusion. Why not start this process right from the beginning? Why to wait for them to get their grade 12th over, or maybe graduation over, and then we are inheriting in them, okay, now you have to start thinking in this order? No, start inheriting this particular concept in them right from the starting, that you have to investigate. You must have seen, these days we always say that the childrens are gadget freak, they know more than us. If you will just give them a mobile phone or an iPad or a laptop, they will be more than happy to sort everything out for you, and you won't be knowing, but the children might know what is like there in it, or they can explore anything new, because you have given them a hold of that particular thing. They have their own gadget, they are exploring it, they know their games the best. You have just bought that game for you, you have given them full advantage that they can explore that particular game. Then why aren't we giving that advantage in studies as well? Not only math, in a complete pack of a study, this should be the involvement of the child, that you can investigate on your own. You need not to mug up the question in the particular manner your teacher has told you. Just try to investigate the problem. What can be the other solution to it? Once they start becoming problem solvers, it will become a lot more easier for them, it will become meaningful for them, and it will become really engaging for them as well. So all the lesson plans that we are curating are based on Cray model. And to my audience, I would just ask you a humble request to just give it a try, because we all are learning everything, like something or the other every single day. So I would just say that if you will start building your lesson plan based on the model Cray, CREI, it will become a lot more meaningful and engaging to you as well as to your mentors. Moving further, now this is my forte. These are all the things that we have curated while taking the lessons. Some are while taking the lessons, some are before the lessons. Now, I was taking symmetry and reflection to a child. He came to me, he said, I'm not able to get symmetry at all. The figures are so tiring, the figures that we are being taught in school, they are so tiring, I cannot understand the concept of symmetry or reflection. Now we all know, when we are standing in front of mirror, we can see our reflection obviously, but this is not where the like child is gonna learn, okay, look, you are standing in front of mirror and you are just looking yourself in the mirror and it's your reflection, your body is symmetrical. It's not going to end over there only. It's a very basic thing that in all the books we can see, like the letters are symmetrical or not, the digits are symmetrical or not, they are getting reflected or not. As I said, learning can be done by experiencing, by visualizing it. I just asked the child, can you get a mirror and a piece of a paper and pen? He just got it. I was also having the same thing. Now, what I did, I just wrote on a sheet of paper A, B, C, D till Z. Same thing I did with unmatched school, same thing I did with numbers. It can be anything. I just kept the mirror and I asked the child to look into the mirror and just tell me, by looking into the mirror, what are the letters that are getting reflected. And it was absolutely clear to that child, okay, this is what reflection is, and this is how I can learn reflection. Because he had a hold that he can use a mirror, he can use a paper and a pen, and they can start learning visually, they can experience it. That is something really important. If a child is experiencing this, this is literally very important. Instead of just writing A on the board and just dividing A from between and asking a child, look, this is symmetrical, this will get reflected. No, we have to make a child understand by making them visualize thing, by making them their experience. Now, as you can see, apart from reflection, there was subconsciously many mathematical concept involved in it, like fractions, like percentages. I just asked randomly my child, he was a sixth grade child, I guess. I just asked him that, can you tell me the fraction of the letters that are reflected to the total number of fractions? And he just answered me, because it was, everything was present in front of him. And then we calculated the percentage. So we are giving them the a sense of learning. We are giving them, we are not holding them back, that look, you have to just learn percentages as per 100. No, we are asking them to explore that this is how you can learn percent. And when this starts inheriting in a child, they will start exploring things, they will start looking at the things from a wider perspective. So this is something what creative mathematics is. Again, I will say, it's not only in mathematics experience, creating math based experience, or it can be creating science based experience. It's up to you how creative you can be in your field. This is our creativity at Unmatched School. It's up to you how you can be creative at your subject. Moving further, I have few slides with me that I frequently use in my classroom as well, and I have a habit of asking these questions. Now, as an audience, you can also think, if I say my television screen is 55 inches, what do I actually mean by that? If we all are gadget freaks, we love gadgets, and it's a human mindset that we say that we want a big TV screen, or maybe we want a big laptop screen, or maybe we want a big phone screen. But when I say that my laptop screen is, let's say, 13 inches, what do I exactly mean by that? What is that 13 inches? The students have a habit of saying, I want an iPad. Have you ever asked your child, have you ever asked your mentor, okay, you are going to an Apple store, you are going to purchase an iPad, you are looking for, let's say, iPad mini, you are wanting an iPad mini, what is the dimension of that? You are saying that you want an iPad of, let's say, 6 inches. So what exactly 6 inch is that the length, is that the breadth, is that the diagonal? So you have to make your child understand by doing. Why not perform this activity and learn the concepts of Pythagoras theorem along with measurement in it? Everyone has a television screen, everyone has a laptop screen, the students have their personal iPad. Why not make the full use of it? Just get a ruler, ask your child to measure the diagonal portion of your screen, the length and the breadth, and apply Pythagoras theorem in it. Because they need not to flip the pages of their book, and they need not to check their answers in the back of the book. At the back of the book, they have the answers right in front of them. Why? Because when they are using Pythagoras theorem, they are proving something subconsciously, and then they are using ruler or maybe measuring tape, and they are measuring the diagonal, the length and the breadth. Might be a possibility that there will be a difference of 1 or 2 inches, but again, they are learning, they are experiencing the thing, which is really very important. And this way they are getting the real life application of subconscious learning approach. Moving further, this is again from my classroom. I was teaching equivalent fraction to a grade 7th or a grade 8th child. Now he was getting really furious while I was teaching fractions to him, and fractions to her and equivalent fractions to her. So I just opened a dot grid in front of her and I said, okay, tell me, can you make a grid? And this girl is really very creative. So I just asked her, can you just make boxes for me wherein the like you have to make four random rectangles or four random boxes wherein all the rectangles that you are making are different, but when you are simplifying them, you are reaching to a same fraction. So I just asked, first go, I just asked her, can you make the equivalent fractions to 1 by 3? You can see on a dot grid paper how she has joined the line, and she has colored the portion, like the numerator and the denominator portion, 1 out of 3, and she has made a fraction. In the second one, she took a rectangle again, she took a square, and then she made 9 columns in it and colored 3 out of it. Again she got 3 by 9. She knew subconsciously that this is again 1 by 3, because when I'm going to simplify 3 by 9, they are going to get 1 by 3 again. So we learned equivalent fractions in this manner, rather than just telling them you are going to get equivalent fraction if you are just going to multiply it by any number. No, this is the need of the hour. Again, we need to make our child experience thing, rather than just asking them to mug things up. That is not at all good for a child as well as for a mentor, because we are living in a scenario wherein we have to interpret everything rather than just mugging up things. So this is very, really very important. This is just a slide that I have shown you on equivalent fraction. It can be on anything. It's again your creativity. As you can see, these slides are my personal favorite as well. I was teaching coordinate geometry to my students, and Avengers, I'm not pretty sure that if they are from Avengers or not, but yeah, they are something, some or the other kind, they are related to that only. So Superman, Nightwing, SpongeBob is obviously different. So in Superman, you can see a beautiful symmetrical structure is always made. In Nightwing, a beautiful symmetrical structure is made. If you will just give them a square, they will get bored for sure. If you will give them a Superman, they will be more than excited to make a logo of Superman, because obviously Superman, Nightwing, Batman, Captain America, they all are child's favorite. And if you have noticed, Superman, Nightwing, Batman, Captain America, the logos are designed in a way that they are perfectly symmetrical. Maybe along, like, it is a possibility that they have one line of symmetry, two line of symmetry, but they are symmetrical. As you can see in Superman and in Nightwing, I just drew a figure of the Superman, and I just asked this child, okay, now can you tell me the coordinate? And he was more than happy to tell me the coordinates, like where the shape, the diamond shape of the Superman, where the coordinates are heading. He was more than happy. Obviously we have to make the child understand what are quadrants, what are like coordinates and everything. The mathematical aspect has to go, but again, they are learning in completely different manner, because it's of their interest. The child starts playing their own game because it's of their interest. They don't like math because math or any other subject is being taught in such a manner that you have to just mug up the concepts, and they start losing interest over there only. But if we are focusing on making math interesting for them, or maybe any other subject interesting for them, that is the very moment where the child will start gaining interest, and they will also start exploring how they can think, how they can just try to explore further. Because when you are showing them Superman, or when you are showing them Nightwing, they are bound to thought, okay, my favorite character is, let's say, Hulk. Is it a possibility that there is a symmetry in Hulk as well? Can I draw Hulk on a piece of paper? They will start exploring, and that is something when they will start learning. In the second one, you can see, in the third picture, you can see that I have made a SpongeBob kind of a thing. SpongeBobs are square, humans are also said to be a square. And like, you can see over here that I was just teaching perimeter and area. And if I just ask this girl that, okay, look, you have to learn that perimeter of a rectangle is 2 times L plus B, obviously she is going to get bored. I explained how the perimeter is going to be of the rectangle is going to be 2L plus B. And then I asked her, okay, I have made a SpongeBob for you. Now, can you tell me that what are rectangles over here? What are squares over here? And can you tell me how are you going to calculate the perimeter and area? The girl was more than happy to do it. They are learning the mathematical concepts, but they are learning subconsciously. They are not bound to learn in that textbookish format wherein they are just writing the questions, they are just putting it in the formula, and they are just getting their answers. No, it's all about interpretation. In this, if you can see, the child is going to explore shapes, the child is going to investigate the perimeter, the child is going to investigate area, and again, it's up to the creativity of the mentor how they can frame different questions and cover various skill sets in just one topic. So I just gave it a name as superhero super math, because all our learners these days are no less than superheroes. Now again, I have a habit of always saying, this is a very famous quote that I always say: math is anywhere, math is everywhere. You must have heard about Leaning Tower of Pisa. When Leaning Tower of Pisa was building, when the builders were building Leaning Tower of Pisa, one foundation was laid incorrect, and they thought, okay, I'll just build this Leaning Tower of Pisa, because obviously we cannot just get everything scrapped out and start building from like scratch. So they just started building, and now what has happened till date, I don't know the year in which Leaning Tower of Pisa was built, but now till date, have you ever noticed that Leaning Tower of Pisa has just leaned by 2 degrees only? And that is the very concept wherein we can start exploring trigonometry there. As I said initially, that trigonometry, you can trigonometry starts in grade 9 or grade 10th onwards. So it's not that it's only for the students of grade 1, 2, 3 onwards. No, you have to just look around it, you have to just look for the options through which you can teach math to the higher level students as well. If you notice my first picture, I just noticed right now that a beautiful reflection of this, of these beautiful buildings, can be seen over here. I was taking a very famous theme from Unmat School, which is Math in the City. In this theme, we take our students to different places of their choices via Google Earth, and then we explore mathematical concept in it. Now you can see over here, I have marked using a highlighter the buildings. Few of them are making acute angle, few of them are making obtuse angle, few of them are making right angle. Now if I ask a child, can you imagine what would happen if this acute angle changes to obtuse angle, or obtuse angle changes to acute angle? Is the building stable enough to stand, or the building will fall? Right then they will start exploring that math is literally around us, math is everywhere, and that is the very moment that they will start exploring things. So this is something, you can see the reflection in the picture clicked, you can see measures of lines and angles in it as well. In the second figure as well, you can see a helicopter chopper is there, so I have marked the angles over there as well, because as I just mentioned, it's completely math around us. In the third figure, I just wrote a name Jack on a piece of paper using straight lines, and then using protractor, I was just measuring it. What are the different angles? Who doesn't want to write their name, or maybe anything, whatever they like? Just ask your child, okay, look, you have to measure the angles. Instead of just giving them angles, why don't we give them just the names? Ask them, you have to write your name or anything creative, whatever you want, and then start measuring the angles. Because what is happening, what we want is, we want them to learn the concept. How they are learning is not important, what they are learning is literally very important. So this is just, I wrote Jack, and there are 90-degree angles, there are acute angles, there are obtuse angles. So instead of just giving them various shapes and asking them, okay, tell me which is having acute angle, which is having obtuse angle, just give them a situation. Feel free to do whatever you want to do, and then come back to me by investigating how you have explored angles over here, what kind of angles are in this, based on like classification of angles based on acute angle, right angle, obtuse angle, and everything. So as I have given the title to this, math around us, literally math is everywhere, math is anywhere, literally. Moving further, To the next topic, math investigation. Again, this is something, this is a proof. Literally, I don't know how to do this proof. As a child, when I was a child, I struggled a lot to like understand the fact that how sum of all angles of a triangle is 180 degrees. This is a very famous theorem from grade 6 onwards, but literally I struggled a lot to understand the concept that you have to draw a parallel line, you have to make alternate interior angle and whatnot. But if I just draw a triangle, I made three angles in it. You can see I have made them in three figures, like three different figures. I just drew a triangle. I cut out the angles. You can see I have taken out three pieces of the triangles. Now these are looking like the beaks of the bird. Now what I did, in these beaks of the bird, I just asked the child, can you just join these beaks of the bird in such a format that they are in the straight line? If you focus on the third figure, you can see the beaks, it's a kind of a straight line, and it's forming a semicircle. Now you can show your child the protractor. This is exactly matching the shape of the protractor, and if you notice, on one side of protractor it's 0 and on other side of protractor it's 180. And therein the concept of sum of all angles of a triangle is 180 degree is very easily explained to a child, that this is how the sum of all angles of a triangle is 180 degree. Rather than just giving them the proof and everything, I understand for getting marks in examinations, getting good score, they have to learn it. But again, if they are learning by doing, they have a clear picture in their mind. I did this activity and the sum was a semicircle. Now they are never gonna say, when they are applying these particular things in the questions, they are never gonna say that you have to they are never going to say that the sum of all angles of a triangle is 360 degree, because it's clearly visible in their mind that I made a semicircle, I joined the beaks of the bird, which is just learning by doing. They are experiencing it. Moving forward, as I say, anywhere and everywhere math. Those who know me, they must be aware that I have been practicing yoga since so long, and yoga is also my forte. So, yoga, I just thought of including blending yoga and geometry, because as a child, every one of us must have heard from our parents, sit straight, don't lean down, sit on a chair and table. When you are studying, don't study on bed. This is where I would say that math is there as well, because if I'm sitting on a chair, I have a habit of now sitting on a chair, because from my mother I have heard that sit on a chair, don't sit on a bed. Your back should be straight. Now your back should be straight means you have to sit in an angle of 90-degree only. There are different poses that you can just explore. As you can see in one of the screenshots, my child was doing she was a grade year 4 year old or 5 year old child, and she was performing a beautiful yoga pose. And therein I told her, Your body is making an obtuse angle." So that is there in the figure. You can say, you can see few people are making, few children are making a triangle. In another figure you can see that our body, when we are performing any yoga pose, the body is parallel, like the body is making parallel lines, wherein we can explore the concepts like alternate angles, corresponding angles, and all of it. So you can include, it's all about your creativity, your forte, your field. You can just try to inculcate things, blend things from one to another. So this is anywhere and everywhere math. You can explore anything. As I was mentioning about 3D shapes or maybe Jenga blocks, learning while playing is the best way to learn, because children obviously love to play, but they are not very eager to learn all the time. So if we are giving them an opportunity to learn while play, they are more than happy to do that. In the first figure, you can see I was teaching the concept of place value to a child. Now, when I'm teaching the concept of place value to a child, they are asking, what does a tens means? If I'm asking them that you have to frame a number, let's say 21. Now I taught them that 1 is ones and 20 means like two tens. So it's not clear in their mind what is two tens. So I just thought of bringing Jenga blocks on the table, and I just asked them, can you make a tower? So they have just made a tower of, let's say, the numbers that I must have given to them is 13 and let's say 14, something like that. So they have made one tower of 10 and then three loose blocks. So they have a clear understanding of how 13 looks like, because if we are asking them 10 plus 3, so they have a tower of 10, they have a tower of 3, they can visualize it, they are getting a hang of it. In the second picture you can see I was just teaching 2D figures. So instead of just drawing the figures on the piece of paper or on my whiteboard, I just asked them, you have to just get flour dough. If you don't have clay dough, don't worry about it, just get flour dough from your fridge. You can ask your mother, make balls out of it, get toothpicks. If you don't have toothpicks, just get matchstick. It can be any material, it's about your creativity, and start building shapes out of it. Now once the child is building shapes out of it, they have a clear picture in their mind. Look, in a triangle there are three sides, there are three vertices, because they can count it. Likewise, we can do it in 3D figures as well. So it's just learning, it's just playing, but at the same time they are learning a lot. As I said, as we are talking about creating math based experiences, one fine day I was just thinking, my child asked me, like one of my learners asked me that, apart from temperature, what can be the real life of integers? And that very moment I also started thinking, yes, temperature has negative numbers, no doubt in that, but what else can be the real life application of integers wherein the child has a frequent interaction to it? Many, like most of us are living in a flat, so you frequently use elevators, or if you are not like living in a flat, you must be visiting your office, shopping malls, anywhere, and you must be coming across elevators. In elevators you must have seen either it's written basement 1, basement 2, basement 3, and few of the elevators are wherein negative numbers are mentioned, negative 1, negative 2, negative 3, and so on. That is where this particular thing, real life applications of integers, comes in. I have highlighted 0, negative 1, 1, everything as well. If you are pressing negative 1, you are going below 0, below basement, because 0, when you say 0, they have a clear picture in their mind that we are on the ground floor. Now if I just want to take my car out from the parking lot, I have to go in the basement. Now if my car is parked in the basement, I have to go in the basement, and that very moment the child knows that I have to go one step down from ground floor, which is 0, and which is negative 1. So if we'll just start exploring, if we'll just start making our child to understand the real life application of numbers, of concepts, it will become a lot more easier for them. On that note, I'll just like Neha ma'am to take over once again. And thank you so much, Neha ma'am. If you have any questions, you can please let me know. I'll be more than happy to answer those questions.
Can I remove this presentation now, Divyanshi, if that's
Yeah,
okay?
sure.
Okay, one second. Okay. Thank you, Divyansh. Thank you so much for that very wonderful and, as you would say, experiential learning type of presentation. And I really like the part where you mentioned how you taught, that kid about reflections and symmetry, because I think even I faced some sort of doubt when it came to reflections and symmetry. And I don't think my teacher at that point of time was so creative enough. I think she just asked me to go through the chapter 10 times, and I just get it myself. So that's a very good idea. And if that's what you're doing at Unmath, you're making maths so interesting and so, hands-on, I would say. Then I think there is going to be a whole generation of children who will not, hate maths or dread maths
Absolutely.
in that, for that matter. Now, my question would be, what would be your advice to parents? because parents resist this kind of creativity. They think, why not just go to the traditional way of teaching and learning, and why, have to be so creative and bring in gadgets and tech into something as boring as maths. So what's your piece of advice maybe for parents who resist such changes, and who how to convince them to that to understand that this kind of learning can also get good marks and also mean something for the child's future as well then.
Okay. So that's a very interesting question, I would say, because I have been interacting with parents, I would say, and
Yeah.
I have been coming across this question again and again, that is this literally gonna help my child? As a mentor, as a content curator at Unmatched School, I have seen a drastic change in my creativity.
Okay.
Now, to answer your question, I would strictly, I would ask all my audience, whether they are parent, whether they are mentors, whether they are guide, that just start exploring this particular thing, because see, a mother knows her child the best.
Yep.
Now you know your child's interest. I'm not saying that it's just the responsibility of the mentor, because the mentor, with the mentor, the child is only for, let's say, 2 hours, 3 hours, or maybe in a school they are only for 6 hours, but again, for the remaining of 15 hours, 18 hours, the child is just with their parent. Now the child, the mother knows their child the best. She knows what are the interest of her child. So what happens is, let's say, obviously parent have to give time to their children, and this is something that is lagging in today's scenario. Now if a parent is start involving, if a parent is involving with their child, again, not only in mathematics, in any subject, they
Hmm.
are seeing that the child is very much interested into Jenga blocks, they
Yes.
should also start exploring things, that how they can teach using Jenga the basic concepts of place values, the basic concepts of subtraction, the basic concepts of addition, instead of just making a child sit on a traditional chair table and asking them that you have to complete it, and once you will complete it, I'm going to give you a chocolate. Gone are the days. You need not to do that, because if you are involving with your child, it will become a lot more learning point for you, as well as for your children, and you will get to know your child much better, instead of just keeping a hold on him or her, that you have to do it in that very moment, and once you are done with this, you are going to get that, you are going to get this. Not at all. You have to just start exploring things, because as I just mentioned, it's not only in Jenga blocks, it's not only in Lego blocks. If you are just going to Hamleys and getting hundreds and thousands of gifts for your child, at least just don't keep them in a box, make the full use of it. Once the child is done learning with done playing with those Lego pieces, or maybe with those Jenga blocks, or any other thing, you are just asking your child, look, आप ये सारा कुछ फटाफट से समेट के अपना रखिए बॉक्स में बंद करके. No, if you are helping your child in cleaning all whatever mess he has created, just explore at that very moment. You can ask your child, okay, आप फटाफट से इसको complete करो, we are going to play a new game with this. So it can be anything. So yeah, so I hope that I have answered your question. This is literally very important, that parents should start giving time to their children, and they should start involving in whatever they are learning. So especially
Absolutely.
millennial moms, because
Absolutely.
millennial moms must have a good hold on like the gadgets and everything. So this is my advice, especially to millennial moms. But yeah, obviously there is no age for learning, so anyone can implement this thing.
That's very thoughtfully answered. And then how about teachers? What about teachers? How do they pump up their creativity to come up with unique ideas to teach various such difficult and such complex concepts? What would be your
Right.
advice for teachers, like in general?
Okay. So in general, I would just ask them, if you are focusing on Cray model, it's not that it has been curated at Unmath, that's why I'm just asking, but in general as well, it's a very simple model: creativity, relevance, exploration, and investigation. So if you
Mm-hmm.
are just focusing on that very model, because I know my creativity the best, I know
Yep.
that I am literally good at yoga, I know that I am really good at craft, I know that I'm really good at math. Now I have few pieces in my mind that these are the things I have in my mind. I can think of this particular thing and I can curate a lesson plan based on that. So it's
Absolutely.
up to the creativity of the teacher, I would just say. Instead of just getting involved so much into the textbook and just thinking how you are going to solve the question, just make the classroom a happy classroom, wherein you are happy as well as your child is also happy, because you are learning, you are playing with your child. Might be a possibility that it won't sound practical to you, but literally I seriously don't remember when I last shouted on any of my child. Literally I don't remember whether it's a group session or a individual session. I never imagined that I shouted on any of the child, because I am not getting frustrated, I am
Absolutely.
learning something new. And that's the very moment when I am signing off from any class, whether it is an offline class, whether it is an online class, there is a big smile on my face and as well as on my children's face. And that is the thing I am making counting for myself as well, that yes, I made this day countable. So that is very important, and this is something that teachers should also incorporate in themselves.
That's very wonderfully answered, and thank you so much for covering so many aspects and so many stakeholders in regards to making maths more interesting. I would conclude with one very interesting comment that has just arrived over here. It's by Mr. Alok Dhaban, and he is appreciating your presentation and saying that this is a very wonderful idea which could be included in the curriculum and is also in very much in line with the new education policy. So
Thank
that
you
was a
so much.
word.
Thank you.
So the audience has been quite receptive. I've been seeing we've got a huge audience watching us right now, and eventually they will
Wow.
also watch after the live gets over. It was actually very interesting and very informative talking to you and watching your presentation. And I think that is also the reaction of the people watching and who will eventually watch. Thank you for a word of advice for teachers and for parents as well. Students, I think they will definitely gain from this advice that you've given to teachers and students, teachers and parents, as they act as facilitators for making maths more interesting. Thank you so
Thank
much,
you so much.
Divyanshi,
Thank
for
you.
joining us, and all
Thank you
the
so
very
much.
best for your future, as you just mentioned. And hope to see you around again soon.
Sure. Thank you so much. It was a wonderful experience for me as well, Neha. Thank you so much, Getty. Thank you so much, Neha. And once again, I would like to thank the entire team of Unmath once again. Thank you so much.
Thank you. Thank you. Bye.
Bye. Bye.